I love being interrupted. So anyhow, as I said, you have your writers and readers, which are all reading from the same shared storage. The replication is basically non-existent, but there are situations where this replication is going to lag, and I'm going to speak about it a bit later. These are the usual stuff that you're probably used to setting up with your Postgres installation. I don't think that I need to explain any of them properly. By the way, if there are any questions, please just raise your hand, and I'm going to try to answer them, because I don't think I'm going to have enough time for the Q&A at the end. What's important to mention here is that actually all of these parameters listed here are automatically configured for you in Aurora based on your instance size. So AWS is going to see that your instance has, I don't know, 8 gigs of RAM, and is going to accordingly adjust each of those settings to fit best with that amount of memory. The one thing that I probably should mention here is the share buffers. It's in AWS, in Aurora, it's configured to use 3/4 of your memory. And Postgres really does not recommend setting share buffers over 32 gigabytes. So if you, by any chance, have 128 gigabyte instance, you're going to want to tweak that share buffers to not go over 32 gigabytes. A bit unusual stuff that you usually set or neglect to set with Postgres and are a bit different with Aurora is, for instance, this one, a checkpoint timeout. It's a thing that you set up where you tell Postgres how often to dump stuff that's in the shared buffers, which is already written in write-ahead logs, to the disk. In Aurora, you cannot configure this. It's fixed to 1 minute, and maximal size is fixed to 1 gigabyte. But in practice, I've never had any issues with the write-ahead logging. In Aurora, you would use write-ahead logging merely for point-in-time recovery and for creating logical replication, which I will speak a bit about a bit later. The auto-vacuum, you should not tune this unless you have a really specific workloads. One of the specific workloads could be that you have an application which is running during daytime, and during night nobody is using it. Then you might want to disable auto-vacuum, and you might want to run auto-vacuum. Actually, you might want to run manual vacuum after business hours are concluded. Probably after some hard details, like you import a lot of data, you delete a lot of data, then you run auto-vacuum so that in the morning everything is set up. Aurora, of course, allows you to configure this as you like it. The thing about effective cache size, which I've been asked a lot in the last like 15 years, this setting never changed. This does not mean how much memory Postgres is going to use. This merely tells Postgres how much cache memory is there on the system, so Postgres the Postgres planner can accordingly plan on the best index strategy to use for delivering data to your query. Checkpoint completion target is also one of the options that's often tuned on the installations on bare metal or in VMs. In Aurora, you don't have this. This one just does not exist, and it's not really needed. The thing about the write-ahead log level is something that you would tune depending on how you want your slaves to behave. Do you want just a hot standby? Do you want a streaming replication with read-only replicas slaves? Or you want to use a logical replication? In Aurora, there is nothing you can do about this. The only thing is that you can enable the logical replication via the RDS logical replication option, and that will automatically set the write-ahead log level to logical. And then you can have separate Postgres connect to your Aurora as logical replication slaves, which can come handy in the scenarios I'm going to speak a bit later. The log retention period is, again, AWS setting for Aurora and, of course, RDS, which basically tells the system how long to keep the transaction logs. So, for instance, you want to keep that to 10 days, and then you can sync in the external slave to your cluster, and you know that you have like 10 days of log files, which the slave can pick up and continue replication from that point. The similar thing about MySQL, again, we have the usual stuff, which are pretty much the same as in Postgres. They're called differently. They behave a bit differently. Again, max connections and DB buffer pool size is calculated automatically in the same manner it's calculated for Postgres. The thing about the DB buffer size, which is kind of the same thing as shared buffers in Postgres, not really, but kind of it is. InnoDB buffer pool size can be super large, and it's usually best to keep it like half or maybe even 3/4 of the memory available in the system. The query cache size no longer exists. If you're using MySQL 8, finally they removed this because this setting actually, the query cache actually created a lot of latency and problems in the multi-threaded setups. It made sense ages ago. There are some applications which are written in a way so that you need this. So when you upgrade to MySQL 8, make sure that to test before you actually put stuff in production, which I even fail to do sometimes. I'll speak about this a bit later. These other options are the usual stuff that you can tune, and Aurora allows you to tune them. There is an interest in the InnoDB flush log at transaction commit, which basically tells InnoDB engine or MySQL when and how to do disk syncs when completing a transaction. So you can tell MySQL, okay, I'm going to commit, but you don't need to write anything to disks because of the performance. You won't want to enable this when loading a lot of data into your database or something like this. The thing is that you cannot really change this. In Aurora, there is another setting which will come a bit later. So I'm going to cover the unusual stuff again. You see, have this InnoDB log file size and InnoDB log buffer size, which actually does not exist in MySQL, so you don't need in Aurora, so you don't need to worry about it. There is these ones which exist, but you cannot change them. So again, you don't need to worry about them. These settings, I'm not sure if they exist. In 5.7, I think they existed. Not sure about 8.0, but they do not apply. If you read the documentation, they do not apply. So again, you don't need to worry about them. The InnoDB lock wait timeout is something that needs to be mentioned. It's basically the amount of time MySQL is going to wait before it kills your connection for the unable to obtain lock. This is difference in behavior from Postgres, where Postgres the default setting is to wait indefinitely for the locks to be acquired. And if you want Postgres to kill your transactions because they couldn't acquire locks for a certain period of time, you need to explicitly tell it to do so. With MySQL, you need to explicitly tell it not to do so with this setting. And this is the one that's connected to the flush log at transaction commit. Basically, if you want to set up your Aurora so that it kind of loses data, you need first to set this option to true. And after you restart it, your cluster, then you can set the flush log at TRX commit to like the unsafe setting. Tooling. This is something that I see a lot of DBAs or even developers who want to dabble with databases a bit more. They would use some graphical tool like, I don't know exactly the name, but the one from JetBrains is super popular, and it's super powerful and super handy. But all of these tools, when you connect to database, they would need to read the data dictionaries about the databases, about the tables, about the constraints, about all of these things. And over a slow connection, that can be really slow. So I would urge you to really spend some time using MySQL or Postgres shells, the PSQL or MySQL. These are command line utilities. They're super powerful. They're getting better and better with each version. You have like the code completion, the query completion inside. You can use Control-R to scroll back through the commands that you have typed before. You can even edit stored procedures. With MySQL, it's a bit cumbersome. With Postgres, you can call the external editor and then edit it and then save it. So familiarize with those tools because it's going to improve your day-to-day work significantly. Something that people always ask me, how are you doing it, is pager. Like MySQL shell and Postgres shell do not have pager enabled by default. So when you type a big query, it just flies through your screen. When you enable pager, it will call less or whatever you have set up for a pager, and it will paginate your output. These particular options here, I don't really remember what they actually stand for, but I know that in my instance, for instance, if the query output is just 2 lines, then the pager is not going to kick in, so less is just going to exit. If it's the output is super wide, it's not going to break all the lines because it's going to leave them as they are, and it's going to, your experience working with MySQL shell or Postgres shell is going to be way, way nicer. Be aware not to set this on the shared servers because other guys might be connecting to them and using it, and then you'll be breaking their workflow. ask me how I know about this. I got yelled a lot, like, why did you do this? Also, one really nice tip is on a shared server, install a utility called SL. And then when somebody types LS, like with a mistake, SL is going to fire up. It's a really nice thingy. I dare you to try it yourself. This is something that I actually learned about yesterday. So the guy who actually helped me is not here, so I'm not going to stand him up for this. But what I usually had was kind of a toolkit, a set of scripts or views that I would create and import into a database. Because, for instance, with Postgres, you want to list all the queries that you're running, and you want to see how long these queries are running. There is no column in the output of the PG stat activity, which will tell you so. So you need to calculate this using now function and the query exact start time. And this is cumbersome to type, like it's a really, really long command. So what I would do is I would create my own set of views. I would import them in the database. I would know which views are those, and I would just say select star from mario.proslist, for instance. But there is a better way. Inside PSQL-RC file, you can create aliases. And let me just try to show you how those work. You can see this right. So basically, I ketted the RC file for Postgres here. You see that I have the set proslist. This is the name of the alias, and this is actually the big query that I'm going to be running. You see at the end now, minus back and start. This is how we calculate the duration of the query. And then at the end, we actually sort it by that duration. So when I connect to PSQL, I just do this. Press enter, and I have it here. Way, way more cool than the views I used to have. So by the time you populate your RC files with the practical stuff, it's going to speed you up a lot, and you're going to be much, much more confident in working with databases. Unfortunately, for MySQL, I don't know of any nice thingy, so maybe resort to those like toolkit views, or you can create shell functions. These are a bit more cumbersome, but if you do them properly, it can also really, really help you. One of the things that in cloud environments usually people neglect on doing is how do I connect to my database? So you probably use infrastructure as code to connect to spin up your clusters, and probably, hopefully, you have your credentials stored either in the AWS parameter store or secrets manager, or you use Kubernetes config maps and secrets. This is how your application knows where to connect and what are the credentials. So going through those manually, or like checking the KeePass6 or the 1Password or whatever to actually figure out where do you need to connect can be super slow and error prone. And if there is a fire, you need a way to connect to the database as quickly as possible. So this is just one example. So as I said, like you need to pull stuff from the secrets manager, from parameter store, from wherever, and create some kind of a utility script for this. This is just the example I created for a previous client, where I would be using kubectl to get the information from config map and from secrets. Because of the way they had it set up, I needed to supply the namespace and the name of the cluster, and I can have these all scripted. So like when I need to connect to betting something, 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 I would just fire up the script with these two parameters, and I would connect in. And this can save you like minutes before you actually figure out where is this that you need to connect, and where there is a fire. This few minutes are really, really going to help you. I'm going to talk a bit about basic maintenance here. I think it's something that you all probably know, but again, I've seen situations where people just neglect some things, so it's a nice thing to go over this once again. Please use CloudFormation, or use Terraform, or use Pulumi, or use any sort of configuration of infrastructure as code tooling, because down the line, you're going to be super happy that you did. Invest some time figuring out how CloudFormation works or how Terraform works. It doesn't have to be anything complicated. You may be saying, oh, I just have one cluster, I don't care about this. Yes, you do care about this. And you're going to thank me later if you actually start doing this. Especially things like master credentials should really not be visible to anybody. So you can use either CloudFormation, Terraform, Pulumi, whatnot, to create a secret in Secrets Manager, and then use your, when you spin up your Aurora, Aurora is automatically going to pull these credentials from the Secrets Manager and you don't even know what the root password is, which is secure and super practical. With AWS, as soon as you spin up your databases, you get CloudWatch logging. Use it. If you don't like CloudWatch, you can use Prometheus, Grafana, Datadog if you want to spend tons of money on really, really, really nice graphs. I mean, Datadog is super cool, but it's awfully expensive. But CloudWatch is really good enough, and you really don't need anything else. So just use it. With CloudWatch, you can easily set, I mean, with any of those tools, you can easily set alerts and have them set up. You want your database to alert you when something happened. But the important thing is not to overwhelm yourself with the alerts. I've seen so many times setups and configurations where there is tons of stuff being in alert state all the time. And when you ask people about it, like, why is this alert? Oh, this is just like, we ignore this. Don't do it. If there is a critical alert that's being ignored, just delete it. You don't need it. Why is it even there? And it creates a lot of noise. So when something serious actually breaks, you're not going to have a visibility about this. And I know it sounds obvious when I'm speaking about it right now, but again, so many times there was an alert, nobody caught it because there was so many other alerts which we just ignored. For the backups, the Aurora, well, AWS in general gives you really, really nice way of dealing with this because you don't have to do anything. You just enable it and it just works. So with the Aurora, backups are auto-enabled. I think the default retention is 7 days, I'm not sure. You can tweak this from 1 day to 35 days. You cannot actually delete backups or disable them, but practice how to do this. Verify that your backups work, restore them, figure out how to do it. Use infrastructure as code to have your databases restored. Again, so many times I've seen databases being or clusters being deleted. Why? Because they were not spun up with the infrastructure as code. Why was that? Because there was a problem. They restored it manually. It was not part of CloudFormation Terraform. Somebody forgot about it, and it just got deleted. Point-in-time recovery, it's also offered by Aurora. Just practice about it, and it's going to help you. You have this thing called enhanced monitoring. Enable it. It's not super expensive. It gives you more information about the instances that your Aurora is running on, like operating system specific stuff, which you usually don't get. And the performance insights is not anymore that new insight, new thing on the AWS. It's basically something like PMM. You have like how many times was this query run, what are the latencies, what rows were taken, and stuff like this. Again, invest time in figuring how this works. It's going to be super helpful. About the upgrades, how do you do it? First thing is like, I want to do zero downtime upgrade. Think about if you really need this. You're not Google, you're not Facebook, and probably you don't need zero downtime upgrades. Yeah, it's a cool thing to do, and it can be done with just a little bit of preparation, but it's better to have a solid plan on how to do the upgrades with the downtime than to have a broken upgrade with zero downtime when you actually have stuff broken. If you need to do it with AWS, you have something called blue-green deployments, where AWS is going actually for you create the separate cluster. It's going to use logical replication for both MySQL and Postgres. Postgres is the WAL files logical replication. For the MySQL, it's a standard bin log shipping, and it will basically do everything for you. All the deployments of Aurora are are deployed in multiple availability zones. By default, if you use more than one instance. And people often ask me, can I have like a multi-region deployment? Yes, you can, but like you probably don't need it because you're not AWS, you're not Google, you're not Facebook. And creating a multi-region deployment is complicated. It can be done, it costs a lot of money, and your application needs to know about this, and there is like a whole spectrum of other things that you need to think about before you actually endeavor with this. So just like ignore it and if you need it, you're probably going to have enough money and people around you so that you know that you actually need this. Some specifics about Aurora, I'm going to cover them super briefly. Oh, I'm sorry. Like the way you configure Aurora or RDS in general is you have these two things called parameter groups, and these are cluster and instance parameter groups. The important distinction between them is that within the DB cluster parameter group, you set up things that are related to storage. And so these need to be set up at the cluster level, like the vol files, the commit rates, all of these things that relate to writing something on this, and on disk. And the DB instance parameter group relates to the instance itself, like CPU usage, memory usage, buffers, and those kind of things. All the parameters for the instance, which are set up in cluster, are inherited on the instance, so you don't need to have separate parameter groups. But you cannot set, for instance, in a DB backup something, whatever, in the DB instance parameter group. One of the things that people usually stumble upon is that the build logs or write-ahead logs are only on writer. So when you have external stuff connected to the your database, it's usually, you need to connect to the master, to the writer instance, being that DMS, being that some other tool that you have. One of the things that people say, like, oh, we hate Aurora because the replication lag is gross. It's not, but if you fire up a large analytics query on the slave, on the reader, which takes half an hour or 45 minutes or 1 hour to complete, and it reads a lot of data from the disk, the writer cannot update that data being read, so the whole cluster is going to hold. So if you need to run large analytic queries, do not run it on your cluster. Set up a RDS instance, just small one, and run queries of that. Use logical replication between your Aurora cluster and your RDS instance. Or you can use DMS to move the data to Athena, to Redshift, wherever you want to do it. But like with DMS, there is one thing that I will probably have a minute or two. Yes, I'll be quick. So I'm just going to quickly go over the pitfalls. The time when I deleted the database. It was a weird setup that we had in the old company that I used to work for. It was on bare metal, and I wanted to delete everything in home directory, which began with MySQL, because we had a setup where all the MySQL, the whole directory was mounted on RAID 10 configuration with fast SCSI disks. It was way before the SSDs came into picture. So I actually wanted to do this. Inside home directory, there was like a lot of MongoDBs and Elastic ELK stuff or some other thingies. But there was a lot of MySQL.broken, MySQL.old, MySQL.this and that. And I needed to fix replication, so I wanted to get rid of all of these directories. But instead of doing this, I did this. The difference is subtle, there is a space. So RM said, fine, I'm going to delete MySQL. It said, like MySQL, I cannot find it, but it also deleted everything else. MongoDB was there, MongoDB just stopped, the whole cluster stopped, and this was actually the ad serving cluster for the adult entertainment thingies. So a bunch of the sites, adult entertainment sites, serving those ads just stopped. And the outage was like 20 minutes. The solution was just to restart MongoDB, and everything was peachy fine. So like, know what to do. With the DMS, I can go in length on explaining why you should not use DMS, and the biggest take is, if you're replicating from MySQL to MySQL, or from Postgres to Postgres, don't use DMS. Use the native tooling. Use standard MySQL replication with bin logs, relay logs. It works on Aurora. So you can slave your local MySQL under your desk in your office to the Aurora if you want to. The same goes with Postgres. You just cannot use streaming replication. You need to use logical replication. Test, constantly test your things. Don't do blind things. This is something that I did, that we failed to do in the previous company that I worked. We were doing the move from the unencrypted to encrypted clusters. And of course, we wanted to do it with no downtime. There was no reason to do it, but the team lead felt like it would be super cool to show the management that we can do it. So after spending months with DMS, I finally realized that you should use like the native tooling. And we had everything set up. And then the team lead said we are going to do upgrades from 5.6 to 5.7. We never tested it. So when we actually upgraded it, there was a bunch of problems, mainly with the way locks are created. The locks are created differently in 5.6 and 5.7. So the latency was super high. We had like 10 hours of outage where people could not log into the system, and all because we didn't test. So yeah, I'm out of time. Thank you very much for being so patient and listening to me. I'll conclude. I'll be outside. Ask me any questions if you want to. Thank you.
Thank you very much for your presentation, and sorry again for the technical difficulties at the beginning. Now we take a 3-minute break for the speaker change, and yeah, the next speaker begins at 11:45.
Odlično.
Can we close the door, please? Jel se ne vidi sad?
Ok, možda da to prvo riješi. Krenut ćemo za sekundu. Ovo riješi. So before we start, does anybody has some experience with reinforcement learning? Excellent, excellent. This is actually for people who do not have so much experience, so you will probably hear things that you already know, but I believe that the complete audience will hear something new. So, hello everyone. Reinforcement learning is a field of artificial intelligence that had some nice improvements in the last years. People are talking more and more about it. My name is Marko Lohert, and in the next half hour, I would like to answer 5 questions. Let's start with what is it? What's the reinforcement learning? Personally, I like to see examples. When I see examples, I better understand things. So the next part will be what is, where is reinforcement learning used? We're going to talk about the advantages. Personally, I don't believe in silver bullet that solves all the problems. So I will also talk about disadvantages. And next, we will talk about algorithms that are used. And in the end, we will see how we can get started with this technology. So let's start with what is it? People usually start with a definition, but I would like to start with a little story, with example, and then work my way up to definition. Now let's think about how biological intelligence learns, how people learn, how animals learn. Well, they learn by trial and fail or success. Imagine we have a dog and we want to teach dog to sit, stand, come here. If he does the correct action, sits, stays, come here, he will get a reward, some food. And by doing the correct action and getting the reward for the action, he will learn something. That's the way that animals and humans learn. That's learning by trial and error or success. Now, let's apply this to artificial intelligence. So I will replace the dog and add artificial intelligence. Pepper, the robot, for our example. If our intelligence does something correct, it will get a reward, or it will get a punishment. So in this way, artificial intelligence will learn what to do. You see, I'm a developer. This is a nice picture, but I need something more specific to work with. So let's work with the standard model, this generic model. The agent, so the dog, the artificial intelligence, will complete some action, and the environment will give it a reward or punishment and generate a new state. You see, agent will take a new action based on both a reward and state. Now, please note, action is called AT. This little t means it is action at a step t, and these are discrete steps. Now, this is the generic RL model. Later on, we will see it applied to some specific model that will look similar to this. So finally, what is reinforcement learning? It's a branch of machine learning. And that branch relies on a technique of learning through mechanism of reward and punishment. It learns the way that animals learn, the way the biological intelligence learns. The agent will choose some action. And now I'm wondering, how will agent choose the action? Well, it's determined by policy. We have this thing called policy that will answer us the question, how does agent decide what to do next? It's probability that agent will do action A in state T. We're talking about probabilities. In this example, we can say that the biggest probability for agent is to do action A2. Perhaps we have already learned that this action is giving us good results. But think about one thing. Maybe this action is leading us to some local maximum. We need to find global maximum. So from time to time, reinforcement learning will try some other actions and see maybe they will lead us to a global maximum. So we can say that what is our goal is to maximize the total reward. In this formula, we can see that total reward is the sum of all rewards in the future from the next step until the end of the episode. In reinforcement learning, we call the episode the vast number of steps that has to be done. These are discrete steps, and we will sum all the rewards, but we will also multiply them with this gamma. What is gamma? You see, we need to ask ourselves, is the reward in the next step more important than the reward 1,000 steps in the future? So this discount factor will tell me how much the reward that I'm receiving in the next step is more important than the reward I will get in the far future. This T is the number, the capital T is the number of steps that is fixed, and that's the number of steps in an episode. Maybe you have seen this formula, a couple of you who already worked with reinforcement learning, this formula but with infinitum sign instead of capital T. That's the other version of this formula, but the idea is the same. We will calculate the maximum reward in the future. Let's put reinforcement learning on the map of artificial intelligence. We said it's the part of machine learning. It's not the only part. We have supervised, unsupervised learning, and reinforcement learning. That's the neighborhood where reinforcement learning lives. Now let's compare it to other types of machine learning. Supervised learning, it has a labeled data set. We can learn artificial intelligence to do something by giving it a labeled data set, pictures of dogs, pictures of animals, and put it into a neural network, and in the end we will get what we expect. This way intelligence will learn. That's the one way. But that's not the way that reinforcement learning learns, because it learns by trying and getting the reward or punishment. Unsupervised learning relies on training on unlabeled data. We can say it, generally speaking, it looks for patterns in data. But reinforcement learning does not look for patterns. It is a different way of thinking about learning from rewards and punishment. Okay, let's see some examples. I will start with the robotics. We will apply reinforcement learning to robotics, but to, let's say, more complex problems. A simple problem in a factory where a robot has to weld some parts together, it always does the same steps, the same routines. You don't actually need some reinforcement learning or intelligence. But when you need a robot that will pick something up, move the object, and move the glass without breaking the glass, you need some more intelligence. Perhaps the most famous example is teaching a robot to walk on the two legs. You cannot learn to walk from looking at the pictures. You cannot learn from just looking at some images. Believe me, I have learned to walk by actually trying and failing. I believe that all of us are learning as kids to walk by actually trying, and if we walk, that's the reward. If we fail, that's the punishment. Few years later, we are getting better at it. Now, I would like to show you the image of the robot on two legs. Perhaps you have imagined a robot with a full human body. Not necessary. it is good enough to have these two legs, perhaps a little bit more complicated. And we can also see this robot dog on the other picture. That's the example with 4 legs. And if you see this robot walking, it walks on a pretty steep hill with a lot of rocks. I could fall on this hill. Another example, gaming. Let's imagine you have a company, you work in a company where you build games. You need somebody to test the game and to play and play and play for 1 billion times. Reinforcement learning can do it by just playing the same game 1 billion times. And it can learn some tricks. Now, talking about gaming, there are some interesting examples. Who remembers this one? Atari 2600. The old gaming system. And somebody over 10 years ago has applied deep Q learning to the games on this system. We'll talk later about deep Q learning as an algorithm, but now let's say that artificial intelligence didn't know the rules of the games. It only saw the its only instruction was to maximize the points. There are many games that were included in this, and the company that does it was DeepMind over 10 years ago. And they wrote a paper on it. You can find it on this link. DeepMind did it 10 years ago. By the way, next year, 2014, Google saw this company, saw what it does, and decided, hey, let's buy this company. The price was, if I'm not mistaken, around $500 million. And I believe that today, with all the AI talks, it will probably be bigger. Facebook was also interested in this company. But perhaps the most interesting part about this company was not Atari games, it was Go. Does anybody know how to play Go? It's a chess play. Two guys in pub. Okay, 2 guys in, maybe more. Okay, excellent. You see that we'll talk about that game because it's the most interesting example that artificial intelligence can play that game. If you have played it, you know that it's actually more complex than chess to play for computers. But before I say a few words about it, I have a confession. You see this breakout game. There is a best strategy to play this game. You have played this game. You have this little platform and you need to push a ball up. And there is a best strategy. Well, my confession is that I have not come to know about this strategy by myself. I didn't learn it from friends who have played this game. I have learned about the best strategy actually from the reinforcement learning when I have read about reinforcement learning and Atari games. What is the best strategy? Well, you need to build a tunnel at one point and place the ball above the bricks, above the wall, and ball will just jump from the roof to the bricks. That's something that I personally didn't figure it out. I learned it from the reinforcement learning. It's a little bit a humbling experience to learn something from the artificial intelligence. One has to think about it myself. But I'm not the only one who is thinking about this. There's one guy, he's good in chess. His name is Garry Kasparov. He has also noticed that we can learn from artificial intelligence. He was talking about the chess, but he can learn some points from artificial intelligence. Now, let's look at this quote. Do you know what's the best part of this quote is? At least for me. The last part, where he says that we can actually learn from the knowledge that artificial intelligence produces. You know, in the movies, it's always artificial intelligence is a bad guy killing people. But in my opinion, it's a tool, and we can use this tool for some interesting things. Well, I have asked you about Go. Few people have played it. So now I would like to tell you that in 2015, the same company, DeepMind, has built a program that it won against the world champion. And important thing here is to notice that in 1997, when Deep Blue has won a game against the best player in chess, people were talking about Go as our strong point. In 1997, people were convinced that artificial intelligence cannot beat us in Go because it's too complex. 2015, we have lost the match. Next, 2 years later, we have a program that is top player in both Go chess and Japanese chess. Anybody know how to play this shogi, Japanese chess? Excellent. One hand, we have one hand. Let's move to some more serious things. Reinforcement learning can be used in healthcare for development of new drugs, for a number of things. If you want to learn if a robot wants to learn how to perform a surgery, hardware is not the biggest problem. Okay, you need top hardware, but that's not the biggest problem. Software is the biggest problem. Trading and finance. Well, if you look at this image, you can see it's really simple. It has more details in it, but it resembles the image that I showed at the beginning, where we have agent. Here we have policy networks drawn instead of the agent. We have a number of actions like buy, sell, hold. We have the environment. What is the environment? Marketplace. We have a reward. We have the reward. And we have the status. Reinforcement learning is actually better at this field than supervised learning. IBM has done some work on this, and as far as I remember, they have actually did some buying and selling using the reinforcement learning, not just a simulation. Went to market, tried to earn some bucks. Well, when talking about self-driving vehicles, I would like first to separate the parts. There are different areas that can be used. It's not just one thing. We can use reinforcement learning for lane changing, avoid collision, automatic parking. There are a number of examples. I will pick one because it will lead me to the next thing that I want to say. That one thing is Wave, the company from Great Britain that's working on self-driving cars. You have this car, and it drives by itself, but it has a driver, a human. And the way reinforcement learning learns here is when the car does something wrong, goes into the wood. Before it crashes in a tree, a human will hit that red button and stop it. And that's the punishment. Here we are learning by the punishment. And that leads me to another thing that I want to say, and that is human feedback. Sometimes in reinforcement learning, you need to have a human feedback. Here is hitting that red button is the human feedback. There are many other cases like marketing, news recommendations. But now I would like to move to advantages. What are the advantages? Reinforcement learning can be applied to complex problems at the dynamic environments. We can learn about things that we as humans do not know too much about. We do not need a separate step for preparing data. And it can be used in environments where the only way we can learn is by collecting data. Now, as I have said, There is no such thing as a silver bullet. So we will need to look at disadvantages. First of all, a sparse reward environment. What does it mean? If you have an environment, let's say a game, where you get a reward when you pass the complete level of a game, then you need hundreds of steps to get to the end of the level. And which of these steps are important, which are not? It's a problem. You need to learn a lot of times just to get to the end of the level. There are multiple solutions. I will talk about reward shaping as a solution, where we only add few new handcrafted rewards. So you get reward not only when you come to the end of the level, you get the reward when you pass every obstacle. That's a solution. That solution is not perfect. What's the problem? Well, you need a human who knows where to place these handcrafted rewards. And humans are not perfect. Reinforcement learning is also data hungry. It needs to collect a lot of data. And when training with the reinforcement learning, be prepared for lots of iterations. We are talking about 1 million of iterations. And I have told you that we learn from trial and error. It's not always good. One thing is to learn in simulation. Another thing is actually to learn with the hardware. If you apply this to a robot, you will get hardware that can break. General advice, combine this with other techniques. Okay, I'm a developer. I want to talk about algorithms. There are a number of algorithms. We cannot go through all of them. We will just see a few famous examples. But at this point, I would like to say that there are two approaches. One is to use model-free, and the other is to use model-based reinforcement learning. What's the difference? Well, there is one idea. We can put some knowledge about the problem inside our system already. For example, if we build a game to build a reinforcement learning system to play Go, we can learn the rules of Go at the beginning, so it doesn't have to find the rules itself. It will make it a little bit faster. I will talk about Q learning algorithm. That's the most famous one. That's the one that we can see here in an example. Q, by the way, stands for quality. What's the idea? Let's build a Q table. That's the central idea. We will build the Q table with state and action pairs. And for every state and every action, we will see what is the value. This will tell us in this state what is the best action. How we will fill the table? Well, let's start with random numbers and let's learn by repeating for each episode. And in reinforcement learning, episode is the name for 1 billion of iterations that is done at a point. What if this is not good enough? We can combine Q learning with deep neural network and get deep Q learning. That is what was applied to Terry, and that's what was done by DeepMind over 10 years ago. So just apply a neural network, deep neural network to this same idea. If you would like to start with this, if you would like to play with reinforcement learning, there are few APIs that can be used. I will pick up one of them and tell you that's name is Gymnasium. That's the fork of Gym, the older system. It's API for reinforcement learning based on Python. It has one agent. It's not necessary to have only one agent. You can have multiple agents. You can use different APIs that already have support for multiple agents. There are different environments. For example, the video at the top is showing us the robot that is learning to walk on 2 legs in a simulation. What are the key points that I would like to share here? Reinforcement learning is a branch of machine learning. There is an agent, one or more agents, that is learning by mechanism of reward and punishment, the way that biological humans and animals learn. You do not need a labeled data set. And now, for the last thing that I would like to share with you, if we have other types of learning, where supervised learning, where we have a data set, can artificial intelligence learn more than humans? We as humans are labeling the data set, and artificial intelligence can learn only what is in that data set. But reinforcement learning learns by trial and error. It learns by itself, by interacting with the environment. So it can come to conclusions that humans did not already reach. It can learn something that humans did not learn. Example, I didn't know which strategy is best in that game. I have learned it by reading about reinforcement learning. We have a few more minutes, so if you have any questions.
Did you try combine two strategy, reinforcement and learning?
Sometimes that is actually the best way to solve some problems. If you have problems like when you need to collect too much data, it takes too long time, combine it with something else. That's the best approach, use deep learning. Perhaps you have worked with some other techniques, combine them. There is no rule that says that we must use only one technique in artificial intelligence. Not talking only about reinforcement learning. In any field, use different technologies. If that gets the job done, do it.
Hi. You said that we can combine reinforcement learning with deep learning to produce some better models in some cases. And I was just wondering, how do you combine both of them? Because to my knowledge, neural networks need to have an expected output for them to learn. Mm-hmm. And in the cases where you would use reinforcement learning, you usually don't have that.
You then have the labeled data set that tells you what is the expected result. Mm-hmm. That's the normal way of working with neural networks. But imagine that you, instead of a labeled data set, get that same information as a reward from the system. You need to move things a little bit around, and neural network is actually using the rewards and the punishments. That is the data that is getting into the system. That's the idea here. This image is high-level image, but that's the main idea. We are running a little bit out of the time. It's great that you have questions. That's great because it means that I have picked an interesting topic. So I'll be here for the rest of the day. Feel free to talk to me after the presentation, at the lunch, at any point. But I think that our time is up, and we will let the next speaker come here. So thank you for coming to my presentation.
Thank you very much for your presentation. Now we have a 4-minute pause and then continue on with the next speaker.
U Hrvatskoj za Švicarce. Ekobit. Pana se nedavno kupio, tako da... Smisle svi još uvijek tu logiran, sam vidio njegovo ime.
Evo, sign out i sad ćemo
Odlično. Valjda svi brzo smetao. Spana se kupio, tako sad ti kažem Ekobit na godinu, više neću reći Ekobit je... Rekli su nam da će nas spojiti.
To ćete se integrirati.
Dobro. Rećemo na početku, ali
Nema nešto svoje. Ništa, puno hvala. Je li ovo vaša voda možda bila? Nema veze.
Yeah, I'll just
Do you need any minutes to do your Q&A at the end?
yeah, I don't know. I think the talk is going to be like 20 minutes or so.
Okay.
I'll try to stick it to 30 minutes.
Sure.
Or do you want it?
It's up to you. It's up to you. I can show you how many minutes you have left. I'll just sit here and I'll show you on the time cards. I just wanted to know if I should show you 5 minutes before your end time so you have time for Q&A or you just...
Yeah, 5 minutes before.
Okay. Need any water?
Oh, I have one.
Hello everyone, welcome to our next presentation called D, the best language you probably have not heard about.
Hello, everyone. So before we start, I'm just curious, how many people in this room have heard about the D programming language? Oh, wow. I mean, they don't count, they're my friends, so... Okay. And how many of you have actually wrote some lines of code in D? Nobody. Okay. So yeah, today I'm going to talk a bit about the D programming language, which is like a really, really cool language that I enjoy a lot working on. It's open source, and I'm just going to show you a bit about what D is all about. So before we get into that, a little about me. So I've been contributing to D since 2016. I actually started my PhD thesis on programming languages, and yeah, it was really centered around D. Since 2021, I became a pull request and issue manager, so it's some kind of a maintainer role, which is actually paid. On the side, I actually enjoy a lot teaching, so I'm teaching some courses and labs at the University Polytechnic of Bucharest. And there you can see my, actually my GitHub contributions. So it's like 500 and so. It's really a lot. Now, what this talk is going to be about, it's not going to be a workshop on D, right? So it's not like you're going to be able to write D code and be proficient in it after just half an hour. But it's more to showcase and give you a feel about what D is all about and how fun it is in some circumstances to write D code, right? So now, a few general things about D. It's a general purpose language. It's compiled, and it strived to be a systems level programming language. So essentially, it tries to be a successor to C and C++, right? So it strives to give you like the performance and the feel you have when you write C and C++ code, but also it tries to give you like the simplicity of Python and the simplicity of Java, right? This is not just a hobby language, so it's been industry proven. I know it's not that popular and it's not used a lot, but there are some industry players that use D and they see it as being their strategical advantage over their competition. And some notable examples are, there's a hedge fund called Symmetry Investments from London. They have like around 50 billion. I don't know if that's a lot or not, but they have been continually growing and all of their infrastructure is written in D. There's also another company, Veka.io, which is an Israeli company, and they have implemented the world's fastest file system, and it's all written in D. Also, there's Funkwerk, that's a German company, and from what I heard, they basically implemented the operating system for, the trains in Germany that they're all automatic. And I don't know if it's like all of the system or some parts of it, but I know that they're using D. So yeah, nowadays when people talk about programming languages, the selling point is like, what's your killer feature? What's like that one thing you do that nobody else does, or you're doing better than everyone else? Well, unfortunately, D doesn't really have that, right? So that's why it's kind of hard to sell in some circumstances. But what D has, and which for me it's very important, it's like a jack of all trades, right? So whatever you want to do, you can do in D. Maybe it's not like the best, but it's still pretty close there, right? So for example, you have a garbage collector, which is turned on by default, but if you don't want to use it, you can just turn it off, right? And you can use manual memory management, or you can use automatic reference counting, or other memory management techniques. It's also memory safe. And again, you can turn that on. So it's not memory safe by default. And in my opinion, it's easier to use than Rust, right? So if you don't care about memory safety, which I would argue is the case for in many circumstances, you can just not use it, right? But if you care about memory safety, you can just turn it on, and then the compiler is going to, slap your hand whenever you do dubious stuff, right? And then again, meta-programming, I would say, so if I would have to pick something, meta-programming would probably be the crown jewel for the deprogramming language. Unfortunately, if you're not a library writer, you probably don't care that much about templates, okay? D also has like an interpreter, right? So it's able to run functions at compile time in certain circumstances. It also has like some concurrency techniques. So for example, variables in D are thread local. So if, as opposed to C++ where they're like global. So if you want threads to share variables, you need to manually annotate them. And then the compiler is going to basically verify that once you access those variables, you're doing synchronized access. Another cool thing is that you can seamlessly interoperate between D and C or C++, right? So it's really easy. I'm going to have some examples and you will see. And now I'm just like going to show you some things that you can do in D.
Thank you for your presentation. Now we are going to go for some lunch. Please, everyone, like yesterday, first exit the space so you can give the lunch coupons to the people and then go back. Track 1 continues at 1:40 p.m. Thank you.
Hello? Hello? Close by? Okay.
Hello, everyone. Hope you had a good lunch. Welcome back to track 1 and the lecture about open source OCR and PDF compression at the Internet Archive.
Okay, thank you. Let me know if I need to do anything for the sound, but I think we're good. So yeah, welcome everyone. This is a lecture about work I did a couple years ago and continue to do at the Internet Archive to improve and completely open source our OCR and PDF stack. First of all, who am I? I'm Merlin Weyer. I've traveled a lot, but I mostly spent my time in Croatia and Bulgaria, and I work remotely for the Internet Archive. And I'm kind of wondering if everyone knows what OCR is or not, because if you don't, I might explain a bit more. So raise your hand if you know what OCR is. Okay, so about half of the room. Okay, I'll explain it. And so this talk is specifically about how we do OCR and scale, and then how we generate a lot of accessible formats using the OCR. So OCR stands for optical character recognition, and a simple way to see it is, okay, I have a photo of something, and there's text on it, but the computer doesn't know that there's text on the photo. It just knows there's a photo and there's bytes and colors, and it doesn't know what's on there. So the OCR is the process of taking a photo, finding all the text, and figuring out what the text is, and then you get like a plain text file, for example, of what is actually on there. We, at the Internet Archive, as a big library and archive, we do OCR on almost everything because we want to know what it is that we have so that we can make it available to people. So if someone uploads a book on, I don't know, painting, and there's certain painters that are mentioned there, then it's nice that they can search for the name of the painter and then somehow find the book that we have on painting, right? That makes it much easier to find these things. Another reason, for example, is if someone is disabled and they can't easily read a digital book, then we can, a physical book, we can give them an accessible digital version of the same book. This is often something that libraries do now, and OCR helps in that process. Another thing that we do is, if we have a book or a magazine, we make it so that you can link to specific pages on the book, and for that we need to know what pages are what chapter starts where, and we also use OCR for this purpose. And this is used extensively by Wikipedia. So if there's a quote on Wikipedia, it will very often link to a book on the Internet Archive, and it will link to a specific page, so that you can see like, okay, this is a real quote, this is what the author said, and this is the book it's part of. And we also use OCR, again, by taking a book and getting the complete text out of the book in text format. We use it to make PDFs with text layers. So you can copy, paste text from books, or we make EPUBs from whatever we find from the OCR process. And full text search is another big thing that I'll get into in a bit, so I won't explain that further here. We process at a big scale, so we digitize books at scale and other materials for archival purposes, and we currently OCR about 3 million pages every day. This figure is actually a few years old because I did the work a couple of years ago, but the numbers hold steady, and actually we OCR maybe 4 million pages a day now. So that's like 40 to 50 pages every second. So I like working at those kind of scales. That makes it a lot of fun. And before we moved to the open source stack that I built on existing tools, we were using something that wasn't open source. It was called ABI FineReader, which a lot of institutions still use. For various reasons, we decided to move away from ABI. I was tasked with figuring out the alternatives. I looked at many different engines and settled ultimately on Tesseract. Again, this was in 2020. With some recent AI breakthroughs, there's going to be much better OCR engines in the future. They'll probably still require a lot more processing power. But at the time, Tesseract was the best engine. I had some prior experience with it in a different project that we had for microfilm digitization, where we have a lot of microfilm rolls, we scan them, and the microfilm rolls contain photos of pages that people put on the microfilm, and then we take them back out, we digitize them, and turn them into individual pages. But we did this at such a scale that the pages were never really straight, because people just put them on the table, they make a photo, and it goes into the film, and then you get like skewed text everywhere. So I used those Tesseract to find the text, find the baselines, and then make it as straight as possible. So I had some prior experience with Tesseract, and that's ultimately why I went with it. The other engines were also good, but Tesseract was the most active. And there's many different file formats, structured file formats for OCR output. I'm not going to go into too many detail, but they're mostly XML and HTML based, and we settled on something called HOCR. So what does this look like? This is an example of a magazine on microfilm that we digitized, and specifically this is a tool called HOCR.js, which takes an HOCR file and then shows every single thing, every single entity in the HOCR file. So there's a picture which is not part of the HOCR file, and then every word has its own element. And then, for example, you can't see it from here, but there's a small piece of text in every corner. So this is the actual word on the document. And then here it also says frequency, which is what the OCR word found. And you can also have it scale the text, but then it would be very hard to read. So you can see it picks up various elements, and even the text that this is a photo. And I built a service so that for every archive item that we have that's publicly available, you can just see what the OCR results look like for every page. And again, we also use this in PDF generation. So I will talk a lot in more detail about the PDF generation, but basically for every document that we have, we take the HOCR result file from our OCR process, we make a PDF, and then try to make it so that the text in the PDF is actually selectable as good as it can be. This means you can select text, copy paste it into some other process, or you can automatically extract the text from a PDF, or you can search. So this is just me searching for the word "the," and then you can see that presumably everywhere where the word "the" or the 3 characters CEHE occur, you can find them. And something I talked about before but didn't go into yet is full text search. So a big use of our OCR is full text search. So everything that we OCR at the Internet Archive goes into a big Elasticsearch cluster. And then every single word that we have, you can search for. So if you just search for the word Linux, you'll get many results. And then I, for example, search for Linux, but then try to only find the earliest possible mentions of Linux. So in this case, there's some magazines like Unix Review and Open Systems Today, and they mention Linux in our archives for the first time from a chronological perspective. And Linux actually started in September 1991, and you can see here in March 1993, there's magazines already mentioning Linux. So this is also cool from a historian's perspective. You can really see when things are starting to be mentioned, and this is all powered by OCR and then full text search. building on the full text search, what we then added is for every single book or every single thing that we digitize, if you click on the previous link, so if you would click on one of these 3 magazine hits, it will actually bring you to the page where the query that you searched for is mentioned. So here it found the word Linux 4 times on page 35. It automatically jumped to page 35, and it highlighted the text for you. So this makes it very easy to search for things in the archive. What I just described is something that we called search inside, so that's searching inside a single item as opposed to across the whole archive. And this used to be extremely slow. So when we were working with Abby, someone contributed or for work made a function to search inside all of this. And the complicated part here is that XML files are really big. Abby XML files are really big. HOCR files are really big, and every time you search for a single word, it would get the whole XML file and parse it completely, and then try to find where the matches. And some of these things are gigabytes big. So we came up with a solution, which was what we get from the Elasticsearch engine when you search for a single word is we get the whole text of the book, and then specific mentions are annotated in plain text, like with 3 brackets or something. So to actually know what match you have to reconstruct the text and then figure out where the actual matches are. If you do that for the whole document, it takes a really long time. So we came up with a simple mapping file, which maps the plain text bytes in a text file to the XML offsets of every page element. So then all you have to do is compare the plain text, find out where the matches are, and then jump to the corresponding XML entry by seeking in the XML file, only parse that, and suddenly everything became much faster. So it really used to take like 40 or 50 seconds to search for anything. Now it's like seconds or less, even on really big books. So a bit more on Tesseract. It was developed a very, very long time ago by Hewlett-Packard in the 1980s. Then Google acquired it somehow. After it was open source, they started working on it. It got much better with version 4, and it has support for a lot of different languages. Even now, I don't know about the really modern AI stuff, but it can do everything from Arabic to Chinese, Japanese, Korean, Indian, all kinds of different scripts. It can do Gothic fonts, other fonts. It's like it contains a lot. So that's been very helpful for us because what we were using before with Abby, it didn't really give us that many scripts, and we probably had to pay for many more of them. It can also detect scripts, so it can tell whether it's a normal font or it's a Gothic font, or this is traditional Chinese or simplified Chinese. And we use all of this to improve the OCR results. And it can also detect photos on the page, which is helpful if you want to ever extract photos from a book, like the photos on the book themselves. I can see if I can put the slides online somewhere, and then you can find the list of all the languages that Tesseract supports, but we also mentioned that in our documentation. Finally, we did a lot of work with the Tesseract developers when I was working on this in 2021, 2022, to try to get the speed much improved, and we got to like a 30% speed increase, which is our scale. It's like really nice. We were at like 15, 14 seconds per page, and it went down to like 10. So, and of course, this really depends on the material. If you have a high-resolution photo of a newspaper, it's going to take minutes. If you have a simple children's book with like 10 sentences, it takes about a second. So, but on average, it got much faster, which was really nice. So taking all of this together, I built an OCR module for the Internet Archive. The entire module is open source. We host it on our GitLab. It's written in Python. It shells out to Tesseract, and all the tooling for HOCR handling is also in Python. And over the years, I've added more support to this. So at this point, it can also figure out if you don't even give a language for a book, there's just a book and we have no metadata on it. It will try to figure out what language the book is in, what script it's in, and then trying to OCR it properly, because if you don't know what language the book is in, you can't really OCR it because you don't know what to search for, right? This is what I called autonomous mode, where it will just detect everything. There's an extensive language and script mapping because many people, they upload books to us, and then we have to figure out what they are, and they might write English or ENG or EN or something else, and there's many more versions of this. Additionally, the module that I wrote can also take our previous OCR results, ABI XML files, and convert them to HOCR, so that we, for older books that we have, we don't have to redo the whole OCR process because it does get quite expensive. And we built our own test deck with some very minor patches, but yeah, so we also have a Debian repo in case you're inclined to get those. And last year, I also added the ability to take a PDF file as input, a PDF file with a text layer, and then turn that text layer into HOCR, so that we also don't have to redo the OCR in case some partners, they actually manually correct OCR results, then upload them to us. So that's a way for us to just skip the whole OCR process and take trusted input here. And you can see this is just some metadata on an archive.org item. It detected the language is German. It's very confident. It thinks the script is Fraktur, which is the Gothic script, the much older script, and yeah, some other parameters. The challenges in this project were I had to work under a specific time pressure, but I guess that's the case with most projects. Handling really large documents was a big issue. Mostly because many XML parsers, they just want to read the whole thing. They don't let you iteratively go through parts of the document. Quality comparison is really hard. If you compare completely different engines, they have different outputs. They have different ways to read documents. So if you have a really big newspaper with 5 large columns of text, some of them might start to read it like this, and others will properly detect the columns, and then you cannot just like run diff on the text output and see what it's like. So it's very hard to do a comparison, but we found that that Tesseract and ABI at the time worked pretty well. Like both of them were similar in quality. There were a lot of edge cases that I had to deal with user uploaded content, because we also have our own in-house digitization archival projects, and then we can more easily tell people what to do and what not to do. But that is not always the case for things that people just upload. So it took me a couple months to work through all those kinks. And at the same time, I worked on PDF creation and compression. That's what I'm going to talk about next. So I guess that everyone knows what PDF is here. Who doesn't know what PDF is? What's the wrong question to ask? Who knows what PDF is? Okay, pretty much everyone. So it's just a universal format to. It's like a Microsoft document, Microsoft Word document, but more universal, and you can just open it anywhere. It's a vector format, and it supports putting text in the PDF, but it's kind of weird. Like it's not like in Word where you would just type things. Text is kind of floating on top of a document in PDF. And we create a PDF for every book that we make, because it's such a universal format that you can open this almost anywhere. We had a lot of different requirements for this. We wanted PDFs with text layers, again, so you can select, search, and people with screen readers who are, for example, blind, they can still listen. They can have their screen reader read out loud what the PDF says. We want it to be very compressed, because we take very high resolution photos of books, a couple megabytes for every photo, and then if you have a 300-page book, you don't want a 300 megabyte PDF, because that's too big for people to download. So we have a compression that we implemented, and we wanted the PDFs to be archival standard compliant, which means that they don't use fancy form features or other things. They're very simple, very basic, and that means that they're archival compliant. And for our process, we wanted the OCR and PDF to be completely separate steps. So it's not like OCR and PDF runs at the same time. They run at completely different moments. So I tried to see how much of this we could just do with existing components, and some things you can do, but none of it really fit our requirements. So Tesseract can make a PDF with text layer, but it doesn't do anything with the images. So then you get a really big PDF. There are some tools like Paperwork and OCR My PDF, which do both things at the same time, and they also don't do compression. So again, that didn't really work for us. I did end up finding a very good Python library called PyMuPDF, which is just a wrapper around the very good PDF library MuPDF. And that's what I used to build most of this. So again, what I ended up doing is I took the Tesseract PDF generation code for text, I ported all that to Python, and then that would make a PDF with just the text, which is completely invisible, and we would then add images to every page afterwards in our generation process. Okay, so MRC is a very old compression technique, And the previous software that we used, which was not open source for making these, did a similar technique. So I based what I did on the techniques that I could find online. But the concept is very simple. You take a single picture and you decompose it into 3 different pictures. The first picture is just the background, which is like the colors, but without the sharp edges, so no text. And then you make a foreground image, which is just sharp lines in the text. And you then incorporate a mask image, which is the third component, which is 1-bit mask that you mix with the foreground that you put on top of the background. And that will make this visually clear in a little bit. The background and foreground is encoded in JPEG 2000 because the PDF format allows for that, and it's currently still the best compression for PDFs. As a file format, it didn't work that well for general users, like it's not supported in any browser, but it is supported in browsers that render PDFs. And we normally downsample the background image because there's not a lot of relevant information there. If you take an uncompressed image, the compression ratio is very high. So you can take a 27 megabyte scan and turn it into like a 52 kilobyte text PDF. And even on our highly compressed JPEG 2000 images, we still get like a 10x compression ratio. And you can tweak these with flags. So this is an example. This is just a book. I think it's the second page of a book where it says like, okay, this is the publisher of the book and whatever. So this is the original image. And you can see there's some noise here, which is, I think, camera induced. And this is the compressed image. So again, you can see it mostly just removes the noise, but the text is still completely legible. And then this image is quite big, and this is quite a small image. So what do the actual layers look like? So this is the background layer, which unsurprisingly does not contain any text. It does contain some shades of green where the text used to be, but basically the software tries to remove all the text and create only a background layer. Then the foreground layer looks like this, which is completely illegible, but it compresses really well. And then if you mix this foreground layer with this mask, which you then, so you combine the foreground layer with the mask and you put it on the background, you get this picture back. So again, this is the compressed version. This is just the background in a simple example. This is the foreground layer. And you can see that the text is here, like there's some black shades there. And that then, combined with this mask, turns into the image we saw before. We can do the same with cats. So this is the original cat image, which is 11 megabytes. And this is the MRC compressed image, which is 244 kilobytes. And you can see there, it's not that different. It's probably hard to see on the projector anyway. But there's mostly just some small artifacts here, some very blurry lines disappear. And then this is what the background looks like. So you can see all the, basically the edges, the outlines of the cats, they disappear, right? Everything around their eyes. And then the foreground looks like this, which again is kind of a creepy image. And combined with the mask, we get the end result. So again, the foreground is basically, there's just nothing until we hit a pixel that's in the mask here, and then we just drag the color downwards. And this is just to make it compress a little better, also for quality purposes, because if you only put the pixel values of the mask in the foreground image, what you get is a very dark image with black around every pixel, which means that there's going to be bleeding of the black pixels to your actual pixels, right? Because JPEG compresses in blocks and it will blend some things around, so that's why we just kind of smudge it out. I had a different version before where it kind of took all the colors and spread them around in circles, which was it gave a slightly better quality, but it was very expensive computationally. So we ended up doing it this way. The mask generation, of course, that's a tricky part here. So how do you know what is supposed to be part of the foreground and what is supposed to be part of the background? And that process is called binarization. And there's many different methods to do binarization, but we settled on a method that's made specifically for text recognition and line recognition, which is called Savola, I guess probably after the person who invented it. And then the binarization, that's my computer. The binarization that we include, so we do Savola binarization, but then we also take the HOCR file. because we know where the text is from Tesseract's process, and we then additionally do some extra binarization just around the words, because Savola in some cases doesn't deal well with inverted text. So if you have a page with black on white and white on black, it doesn't always find everything, and this then helps further improve the foreground and background generation. I wrote all of this in Python, so Python compiled to C. That was quite fast, and a good friend of mine, who actually now works with us for the Internet Archive, he wrote a much faster version. So now you can compress pages at 2 seconds per page, 3 seconds per page. Again, so the way our process works, Tesseract creates an HOCR file per image, and then we have tools that take these HOCR files, turn them into a big HOCR file, and then a PDF is made with just a text layer and no images whatsoever. And then we compress the images, insert them into the PDF, and then we make it archival PDF compliant, which is really just adding some markers, and then everyone's happy. So it used to be quite slow. It used to take about 20 seconds per page, and then after a lot of optimization, it went down to 7 to 8 seconds per page, and then we got it down further to about 5 to 6 seconds per page. But again, this depends on the stuff you're working on. And we work on very high resolution pages with a lot of text usually. So these numbers might change, but basically this shows the different versions of the software getting better. And the peak memory usage also dropped by a lot, so it's now a lot more stable. Again, this requires collaborating with the Python MUPDF library and other people. Okay, so the source code's online. This is the OCR module that I mentioned before. These are all the tools for generating HOCR files, taking them apart, taking a PDF, turning it into an HOCR file, all these things. That's all here, including what I use for full text search or matching specific parts. And then there's the archive PDF tools repository, which does the PDF compression. Again, both of these are HTTP3 licensed, so it's completely open source. And then we have two HTML help pages on what these modules do and how to use them on the Internet Archive. And I also have some hosted documentation here. I think there's now also a read the docs link, which is probably more up to date than my version. Finally, I collaborated a lot with the community around OCR. So OCRD, I think, is mostly a German project, but they do a lot with OCR, and they work with a lot of libraries in Germany. They were very helpful. The Tesseract developers were very responsive to issues and bugs. So we worked through many of them because we do it on such a scale. We run into all the edge cases constantly. MUPDF and PyMUPDF are great projects. And if people are really interested in OCR, you can join the Slack that we use for work. Just send me an email and I'll have you invited. It's not an IRC channel, but it's work, so I can't help that. Ever since the end of 2022, everything is now at the Internet Archive is open source, whereas we used proprietary stuff before. We built MRC compression in Python for PDFs because it didn't exist. I think there's other libraries that are now starting to use our software. We process millions of pages every day, so I didn't do the calculation of how many we did since that moment, but it's a lot. And we're very happy to work with other people to make the software better. I'll take questions now.
Thank you for the nice talk. Really good, interesting. You mentioned in the beginning that now that we're actually already entered the era of AI and everything else, we might expect something good to come out soon or in the next whatever, probably highly likely some new tools will emerge that will raise the quality bar for OCR. Are you like, from your standpoint of view, are you like looking already at something at the horizon that could potentially improve the quality of your work? Speed?
Yes, yeah, there's several engines now that are getting much better. I will give the names to you after the presentation because they escape me right now. There's one driven by a Chinese community, and there's a few others, and they really improve also on the layout analysis, which is Tesseract. I think its weakest point is layout analysis. So if it's a very complicated page with tables, it will not really understand what's happening. It will find the text, but then the layout is not that great.
Like a newspaper or something, right?
Newspapers or yeah. there's many, or magazines with ads in between, and then the text continues somewhere else. Or if the text is too close, it can also get it wrong. And that's I think, from my perspective, the greatest weakness from Tesseract. The reason that we are looking at them but are not switching is because Tesseract is really stable and it's really fast. You know, if you have a single CPU core and you can do one page in 3 seconds, you cannot do that with, you know, whatever the current AI. You need to buy a lot of GPUs and
Right.
yeah.
Okay. Thank you.
Sure. I'm happy to talk more after the talk.
Yeah, I have a few questions in one. So first, what's the error rate in the text? How many errors are, how many words are wrongly detected? And do you maybe do you have plans to add some post-processing step with a dictionary or something like that, or AI in the future to correct that? And the other question is, where's the, I mean, what's your actual computing power for that, and where is the bottleneck? Is the bottleneck in the processing or in the bringing new materials to the?
I see.
Do you even need to get faster, or? Yeah.
I see. Okay. Yeah. So to the first question, which was about error rates and if we have better ways to get rid of errors. So we were in, like, typically OCR 95% is pretty good. I think we're right around there. It's nowhere near 99.95 or something. If the book is very clear and simple, then we can get very, very good rates. But again, it's not as good with Chinese, for example. It's decent, but it's very, very complicated to do error analysis, because if you don't read Chinese, then you basically cannot. So you have to find someone who is willing to spend the time, and then they have to, I guess, count the characters and then divide how many. So in our assessment, we were similar to Abby, which was good enough for my boss. So I unfortunately don't have an actual number. And as to the making it better, I'm hoping to develop something so that people can submit corrections manually, and we could then use that for some correction training later. To the scale, we basically run at our limits all the time. So if we need to extend our limits, we'll buy more hardware, but we typically get as much in as we can process, and sometimes there's a backlog for a couple of days, but normally we work through it pretty quickly. I did try to optimize it to be really fast. I think our main issue, honestly, in our cluster is I/O speed. Everything is hard disks, and then if someone might module that's not very good with hardware, hard disks, then everything else slows down.
Thank you.
Any more questions, or are we out of time? I think we're. I don't see any more questions, so, but you feel free to ask them outside as well. Okay, thank you.
Thank you very much for your presentation. We will now take a 4-minute speaker change, so the next talk starts at 2:15. Thank you. ću vam samo napričati o mikrofon jer imamo stream.
Okay. Hello. Spremni? Ok. Hi, ja sam Noa i danas ću vam, odnosno ćemo engleski, hrvatski. Anyone here needs English? Okay, great. We're using English, finally. So, this is the latest version of my touring presentation, Unveiling WASM-COV, where I'm showing you how to fix a really stupid compiler bug, but I'm taking 30 minutes to do it. Just kidding, it took me like 2 months, so I want to spend at least 30 minutes talking about it a few times. So a little bit about me. I'm a freelance security researcher, and I've been coding for a long time. I like Rust, TypeScript. I don't really like Python, but it's somewhere on that list for reasons unknown. And I also use Solidity because that's where the money is. I made WASM-COV with Bartosz Barwickowski at Hacken, which is a security consulting company I worked at for the last 2 years until about like 2 months ago. Of course, I left them all the worst bugs to resolve and all the worst issues to maintain. Just kidding, just kidding. Not kidding at all. So by the way, I also do fuzzers, general like security auditing. I had like 120 audits at Hacken of like various blockchain projects, which are like the highest risk banking system you can imagine, right? With zero regulation, and none of them got hacked. And you know, those things, they get hacked all the time. So I'm pretty happy with my general, you know, results in ensuring that people are following good procedures. And today I'm going to be telling you about the tool that was created during one of those audits, WASM-COV. So first we need to get into some details of WASM. So these are 3, oh my God. I know what happened here. One moment. There is a mirror somewhere in here, and this is my, oh boy. Yeah, just imagine that there's very nice logos here. It seems that I have dark mode on. So there's these 3 chains, like, or chain SDKs, Polkadot, Cosm, WASM, and Near. Okay, actually, it's fine. Actually, it's gonna be a problem later. Oh my God. Yeah, one moment. It's like really amazingly hard to do this. Like there's a tiny screen that I have on the counter side. There we go. Okay. So Polkadot, Cosm, WASM, and Near. What do all of these have in common? They're all like layer 1s, which is a magic word that you probably do not know, hopefully. They all use WASM, which you may guess from the title of the talk, but what they really have in common, and what a lot of other things also have in common, is that they all use coverage tooling, which allows you to get like 100% test coverage, which is a pretty good result, right? With code that doesn't actually even work when you try to run it on the blockchain. So how is that possible? Well, let's take the third one, Near protocol, for example. So Rust has some, Near protocol is written using a Rust SDK primarily. They also try to make a JS SDK, but let's ignore that. It's not for production use. And while Rust has coverage solutions like LLVM-COV through their LLVM compiler and Tarpaulin, which is older, those don't really apply to WASM running on the Near VM. For instance, you may have a smart contract with this like payable macro, okay, which is a common way to do things in Rust. Payable just means that it can receive native tokens, so you know, on a function. And you may think it's too early tested because you wrote tests that call that function. You wrote like normal unit tests, and you measured the coverage and it came to 100%. But the grim reality is that you were never really testing the code that is gonna run on the blockchain. You see, the coverage that you measured was on an x86 runtime, while the blockchain is running WASM. So this means you deploy your contract, your project, or whatever, and nobody can use authenticated functions because those functions cannot accept attached funds, and attached funds are a way to do authentication on near because reasons. And that is because you actually forgot the payable macro, and you forgot the payable macro because, your test suite lied to you. And I'm not making this up. This is a real world example from an audit I had, right? And they will be remembering this, and they will be making a very, very stern to-do about adding integration tests, okay, along with this macro. But this got me thinking, okay, this issue, I found it manually. I'm a very, very, very diligent code reviewer, okay? But what if there was some other way to get around this problem? Like, how can we make sure that this never happens again to anyone? And the answer is sort of simple. Test coverage. All you need is test coverage, the actual good test coverage, not the fake one. But how come there is none? How come that nobody solved this before, and that these projects, that have been around for a while are all using faulty tooling? I mean, Rust is using faulty tooling. And the answer is that it's not really that easy, okay? This is a fairly niche area. WASM is a niche, unstandardized area. WASM is only getting file I/O standards like this year, okay? And the solution, it doesn't readily present itself. It requires understanding and tampering with compiler internals, something that most normal developers will not be doing. So let's do it, right? Let's talk about compiler internal, let's go. Intermezzo to Rust's implementation of LLVM, okay? So, traditionally, Rust is built on top of LLVM, okay? So, tradition was that compilers went directly from source code to object files, so assembly, right? You had a C compiler for the x86 platform, and that was just like one vertical. But then somebody had a great idea of making what they literally called a front end for programming languages. How that works is you have your language, right, whatever. You have some intermediate representation, and then you have your target architecture. And whatever you're doing, if you're adding, for example, a whole new target architecture like RISC-V, you just add one path from LLVM IR to RISC-V, or WASM, same. If you're making a new language, you just add a pathway from the language to the IR, and suddenly you're available on all of these platforms. So really great way to make stuff interoperable. And LLVM is a pretty big foundation at this point. They've been running for like, well, longer than I am alive, I think, or just about so. And they have this coverage tool, LLVM Cov, okay? And it supports a ton of stuff. But WASM is not very standardized. Despite being used in production a ton, especially in blockchain, with a lot of money on the line, like literally, Turing complete banking system level of money around, it doesn't support WASM, okay? So why doesn't it support WASM? It should. And that's where we get to the inception of WASM Cov, by taking a step back, okay? So blockchains and bare metal environments, these are all like they tend to be very low-level VMs, okay? Ignore all the consensus stuff. Ignore Bitcoin, which is like the first one with just basic transfers and UTXOs. All of the rest of them more or less have some sort of virtual machine, okay? And it's gonna be a very low-level, very custom virtual machine. And it's also gonna be a very basic virtual machine. Especially for WASM, it's gonna be a custom domain-specific SDK plus a very limited virtual machine that doesn't support file writes or profilers, because you do not want to run those when you're writing code like it's the 70s and you're trying to launch to Apollo with hand-knitted code. Seriously, running code on blockchain is expensive, very, very expensive. Like, to give a good example, you want to write like 300 lines of code or something like that, like something very basic that just holds balances of users, a token. And you make a mistake, you just need to edit the line of code, so you need to redeploy the whole thing. Easy, right? Nope, costs about $1,000 at peak time on Ethereum, okay? Very expensive when you're trying to do decentralized code running. That means that even if we somehow manage to get a profiler in there, we're gonna need to make something extra custom to get it out. So we're gonna be looking for inspiration in how that's done on bare metal environments, where you also have pretty much nothing, and you're just trying to figure out a way to even get your profiler data out, okay? And this is, I think this is the right conference to actually find people who can lecture me on that. So a general breakdown of steps. First, somehow enable generation of code coverage and profiler data in a WASM runtime. Step 2, find a way to extract the data from the runtime without having file writes. Step 3 is some magic I'll talk about later. And step 4 is generate a human readable coverage report. Okay. So, step 1, how do we get coverage instrumentation? Honestly, not that hard, not that hard. Rust about 2 years ago, and that is when I was like, okay, now I can use Rust, because I'm a pampered kid. I like using finished software. About 2 years ago, they stabilized instrumentation for coverage, and I was like, I'm gonna use this now. So it's pretty easy. You just add some flags to the compiler and blah, 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 and it runs. By the way, you also need a no profiler runtime if you're going to WASM, because WASM is a no profiler runtime. You also need to fight the linker for 3 hours, by the way, or more. The answer is similar to the networking people. Here, the answer is always link time optimization, not DNS, okay? And we have a binary with instrumentation, great. Next step, extracting the data. This is where we get to the custom VM does custom stuff part, and we actually need to modify the VM a little bit. This is gonna be something along the lines of adding a new utility function somewhere in the VM that allows us to capture and extract the coverage, okay? This is gonna be custom to every single VM because they're all very customized and nobody's really following clear main. Everybody's vendoring their code, okay? Everyone's vendoring their code, in short. So we use Minikov, which is a very nice utility for getting profiler data in a no profiler runtime written in Rust, okay? For LLVM profiler data. And then we just call a custom function that we write as part of the VM, or we pipe the data somehow, like in another way, for example, through logs, or who knows what, just putting them directly on the blockchain storage. I mean, we're not looking, we're gonna be running this locally. We don't really care about bloating stuff. We can just delete it, right? And this can be very tricky. This requires you to actually know very well the environment you're coding in. And it's gonna be like, like a whole new programming language, honestly. And step 4, that's why I'm skipping step 3 and making it question marks. An unusual compiler bug. So we got the coverage data out. We spent like a month just working on that. I mean, this is not full time, by the way, but it took time. And we're like, okay, now this should be working, right? We have some profiler data, we have a binary in WASM, and now we can show some coverage. But it's like, what? No, nope, there's no coverage data here. I can't show you anything. So what do we do now? You look at the profiler output files, they seem okay. They seem to have correct coverage data. When you go and try to merge them or check the prof data, they're okay. And you spend 3 weeks, you don't talk to your friends or family until you get to this. And this is where we were first, So coverage generation doesn't work by default because a WASM binary compiled by LLVM is not going to have an LLVM cov map section required by LLVM cov to generate the report. This is an LLVM compiler bug level thing that affects, I think, most everything compiled by LLVM. The reason to WASM, the reason I know is because the IR, the intermediate representation, is fine, and I had to learn to read that. To fix this, we learn a bit more about the internals. So we take a look at the compilation process. We push this emit LLVM IR flag, and we just get the IR in the process. The IR is still fine, okay? And this is the tricky part. So we know that there's something broken about compilation to WASM. We don't have much time, and we want to get this usable for people who actually need it as soon as possible. So we just take this IR and we cross-compile it to x86 architecture, because then the coverage is sort of gonna work. Okay, but now we have a problem. We had some WASM-specific stuff. You know, memory is done differently. We don't have a pointer allocation like we do in x86. We have basic memory grow, memory shrink with a custom, with literally a custom allocator. So we can, I recently had a deep dive into allocators as well. But in short, you can do very, very freaky stuff in WASM with allocation. So we also stub all functions. That means we keep the coverage data, but we sort of get rid of any logic that would be problematic to compile to x86 because it just doesn't exist, okay? So we stop that with unreachable or something, cross-compile, and then when we pass it to the LLVM cov utility, we can actually get the coverage report. And whoopsie, and that works, Oh boy, but this doesn't. Come on, this is not nice. But wait, there's more, of course. So this took a while, okay? And this took very, very, very skilled engineers working for a while just to get it working for one thing. But we want to make this easy to implement, okay? We care about security and we care about sharing it with people. So we made this like little utility library, had like a few different iterations, which is what WASM pretty much became, which also included all the cool stuff, you know, like managing target directories, managing compilation profiles and flags for different environments, managing the tools that you actually need to locally have installed. So you're not going through like a 700 step dependency tree just to get this working. We didn't want to make it a bit like a, you know, a Stack Overflow issue with a very, very vague answer and nothing better. I want to make it easy. I want to make it, you know, Apple level easy. Couldn't really reach that because it's compiler internals, but I'm pretty happy to where we got to because, and I took some inspiration from Cargo LLVM cov. So I expose this as both a library, which you can use in C or in Rust or in whatever else you want, and as a command line interface, okay? So the process is more or less the same. It's just a slightly different, you know, syntax. But first you run the setup command, which sets all the environment variables, etc. Then you build your stuff. So this is for Rust cargo build, which is then built with those and variables. You run your external tests however you want, which are going to be using your compiled WASM binary. And finally, you run this finalize command that does all the cleanup. Within this, all the complexity of, you know, literally editing the intermediate representation, emitting it, having different WASM files, some of which are edited, so you can actually cross-compile stuff, blah, 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 all of that is solved. Target directory management is also solved, because if you're gonna be changing where the WASM file is going, etc., you're gonna have issues there, okay, with the LLVM cov. So a ton of these little low-level bugs from necessary tooling, like actually installing LLVM, are solved. And you know, this is also open source, so anyone can just, you know, take it and re-implement it themselves. This is more or less how it works. Let me see if it's gonna run fine. Come on. Yeah, sorry, we didn't have, I couldn't get Wi-Fi here, so I'm running off a hotspot. Yeah, but I couldn't connect earlier. Okay, in short, it shows the running of the tool and the generation of the coverage report, and then you can see the finalized coverage report with everything sort of nice. Come on. And in the end, since this was initially created, I've been following the implementation by other communities, by other projects of the tooling and the method, okay, extracted from the tooling. And I've seen WasmPack, WasmBindgen implementing this in terms of like more low-level Rust protocols. I've seen Near and Radix implementing this as clients of Hacken. And I've also recently noticed a movement for Cloudflare workers to get actual coverage because there's a push to replace Docker with Wasm workers, and those things really need coverage because, I don't know, here's a random bug, okay? usize, okay, we have usize in Rust, and that's like the size of an array as a type, or like memory allocation size. And on x86 platforms, sorry, on 64-bit platforms, it's gonna be a 64-bit integer, right? But WASM is 32-bit. So you're gonna have a type mismatch here that is gonna cause critical crashes that are only gonna be happening on WASM. And you're not gonna be catching that with local tests unless you're actually running them on, 32-bit architecture. And that plus all the memory allocation issues and differences, etc., like, it all really, really adds up. So that's sort of the idea. Let me see. It seems I will not be getting the demo. But that is it in that case. Thank you very much for listening, and on to the Q&A. Go ahead. In case you don't have questions, then give me feedback about what you didn't understand, because I'm trying to improve the presentation every time so I can get more questions and people actually understanding the topic.
I guess for people who are not into solidity and like I touched it like 5 years ago, so more or less I got it, but like it took me some
This is not a solid thing at all. This is Rust and C and whatever going to WASM. So this is not blockchain at all, this is WASM. Because, if I make a mistake in my code and it's running somewhere and I get a bug in a worker, no biggie. If I make a mistake in my code and it's running on a blockchain, biggie, 50 million down the drain, okay? Let me see if I can. So it looks like a normal LLVM COV report. I don't know why I have issues with, I was trying to get the connection down earlier, but I'm not sure I'm gonna have luck here. It looks like a normal report. So you have this specific stuff about region coverage, etc. You maybe have a hotspot that you can share, because I'm not, the Algebra hotspot never worked, and DORS CLUC, everyone gave me different passwords, but none of them worked. Open forever, because they told me DORS forever. Wait, I think, okay, wait, is DORS actually working? Okay. Okay, I think DORS is actually working. Let's see if we can start. Okay, so this is like the Radix demo. The cool thing about recorded demo is that I can cut out the compilation time, because there were another 2 minutes of compilation in there. And you get the coverage report. It also covers all your dependencies because it's a little bit raw. LLVM doesn't quite support branch coverage yet, so that's a known bug. But you get coverage of your normal thing, and you get line coverage as well, all the region coverage. So line, region, and function coverage. And region is a bit like branch, but slightly different. So region is whatever is between the curly brackets. And you can see that all the code is correctly covered. That's the demo. So yeah, it works. Right now, I'm not really the active developer of this, but it's been a joy developing it, and I'm really happy, especially about the Cloudflare workers push, because after like FOSS Day in France, it was like there were some good conversations about about who could start implementing this, because for example, Phantom, I think they run like they are actually replacing Docker containers that run Linux with Docker containers that are really running WASM. I think it's Phantom or no, I forgot the company name. Don't kill me. But the thing is that like with WASM, you get massive, with the Docker container, you need to spend like between 10 and 50 seconds booting up the container. Here you just have binary and you run the binary instantly, no boot time, like 40 milliseconds or something. It makes it fast enough to have actual, Edge or whatever serverless functions that are, user-friendly and fast. So that's a nice thing about WebAssembly for that. I mean, it is a web technology for very, very fast stuff. Okay. Plus, the general paradigm about, portable code, like truly portable code. But honestly, I think LLVM IR provides that, and, Java did that as well, and look where that got us. So yeah, that's it. I think my time is up. So thank you everyone for listening. In case you have any questions, you can catch me outside, and see you sometime else. Maybe if someone is in Belgrade in 2 weeks or so.
Thank you, everyone. We will now have a speaker change, and the next lecture starts in 5 minutes. Test, 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 test. the sound. Okay. Yeah. You can actually start. I'm gonna just read your presentation name and get you started. Can we close the door, please? Thank you. Right? Yeah. Okay, hello everyone. Next up we have a mesh text stick and a demo.
Who's here has heard of something called LoRa? LOR. Okay, good. Okay, we've got a couple of people. So Meshtastic is an open source project that leverages LoRa boards, and there's one there that can send mesh communications from on a point-to-point basis, and then if you can't get to the node you want to get to, it connects to a mesh. And it's very cool, but something that's really depressing is in Zagreb, there's nothing. I mean, we're all here, but there's nothing. But if we zoom out a bit, whoop, no, not that one, whoops. It's good. Okay. Right, well, that was meant to be the map, and somehow it's not working now because my browser is frozen. But basically, there are lots and lots and lots of nodes everywhere, but almost none. There are none in Zagreb, and that's not what I'll forget that. Yeah, I've got too many browser windows. I could try. Yeah, that one. There we go. Okay, we're back. So if we zoom out, we'll start seeing that there are many, many, many nodes that are all meshed together. And this is something called mesh map, and it's just indicates how many connections there are, how many nodes there are. It's growing all the time, and what it's capable of doing. Well, actually, there's even up here. It's I probably won't be able to show it. Oh yeah, there it is. Can everyone see what that says? It's Santa Claus. So they've got one on his sleigh. So essentially, it's super easy to set up. You go to the Meshtastic site, you download the appropriate firmware from the board for the board you buy. They're very readily available, just about, well, millions of different boards or hundreds of different boards from different manufacturers. And you load it, you set it to the right frequency, and if you're in a relatively populated area, you'll be able to connect to other people. It's line of sight communication only, but as I said, it then could create a mesh amongst other things. The transmission, the distance of some of these things in a line of sight basis is something like 100, 200 kilometers on a clear day and from a high elevation. So I'm actually just going to start something. I'm going to take that. Just you'll see something change there because I've got another one just here, and there just to be clear, I'm turning off my Wi-Fi, and I'm going to go to the next tab. And there's a Python app, it's about 6 lines of code that just repeats and starts sending the same message over and over. except when it fails. You should be getting something. What's it saying? The message is new. Yep, and so they'll keep on repeating every 10 seconds. If you want to pass that around to people once they... So what can you do with these things? They're based on boards like the ESP32, which is a sensor board you could connect anything to, like you know, gate openers, presence detection, you name it. You can actually plug it into one of those boards, and then you can put that board somewhere else within radio range. It doesn't depend on the Wi-Fi or cellular networks at all. So it's completely off-grid, which kind of makes it attractive to a certain class of people. You can send text messages. You can also send JSON or XML. I haven't tried binary yet, but I'm pretty sure that's all possible too. It's low bandwidth. You're looking at probably maybe a couple hundred bytes a second. And there are different channels. So you can have an encrypted connection between as many nodes as you like. And I can show you. So there is, on these boards, there is a Wi-Fi connection or a Bluetooth connection. And this particular board has got a Bluetooth connection to this phone. And Bluetooth. And the way you set up a connection is you just you set up a code. It gives you a QR code. I could share my code with you, and then you could connect your device to my network. And you can have up to, I think, 8 channels. So that's kind of it. It's really it's a layer 2 kind of discussion. It's quite simple. I don't know any of the ins and outs about it. I know a little bit more than that, but that's kind of it. So if anyone's got any questions, I told you it's a short presentation. I've only tried the Heltec. I've actually taken delivery of this about two weeks ago, maybe three. And Heltec version 3 is very compact. It's got no sensors in it. It's got the standard ESP32 pinouts. It runs its own version of the Meshtastic firmware. I'm not sure if you can put MicroPython or anything like that on it, but certainly you have other boards that have GSM modules on them, all sorts of other things as well. So, anyone else?
So you said it's a radio frequency based.
Sorry, say again?
It is a radio frequency based?
It's 868 megahertz,
But
so it's public band.
But who's transmitting? I don't understand how is the network working? Is this a receiver or a...
So there's one of these which was dropped just before it came in.
Oh, okay.
So it's in bits. So it's all very robust, actually. It survives dropping. So it's sending 868 megahertz packets from this one to wherever the other one is. And that is also linked to this device, and I'm getting, my phone is buzzing. I should get it on. Every time that this sends a message, it goes to that device, and then it Bluetooths the message to this phone. Completely offline. This PC I've just taken it offline. and it's connected by serial only to that system. So it's completely disconnected from the mainstream networks. So for example, if you're a skier or you want to be, found in the mountains or something like that, and you have people that are part of your mesh, then you can put one in your backpack, and hopefully it'll help people find you. I'm not sure I can hear this, it's beeping all the time for every single message that is sent. It's perfect for sending small amounts of data for whatever you want for monitoring of systems or gates or doors or water tanks or water temperature of a local pool, which is what I want to build it for. But yeah. Any other questions?
Also, I could technically use this as like a home monitoring device wherever I go, basically.
Can you define the question a bit? Like,
Just, I don't know, my system in my basement,
yeah,
like my rack,
yeah.
performing some just basic data like I don't know, throughput or what's going on. Just some basic manual way, for example. I'm not in a place where I can have Wi-Fi, for example.
Yeah, but you still need to be in range of a mesh. Yeah. So if you can, the message that I want to send to everyone in Zagreb is start buying these devices. They're $20 each, and start creating a mesh of your own, and then you'll be able to connect. Thank you. You can also connect it to an MQTT server. I think it's a one on meshtastic.org, and that allows you to relay messages from country to country, from cell to cell, and from mesh to mesh. So they thought a lot about this and how it works. So in your scenario, you need to be part of a mesh though. Yeah, no, it's fine.
Can you DDoS this? Like, would you be able to like send so much data and messages and whatnot to overwhelm the mesh?
That's a question for people who know more than I do. Yeah, I haven't heard of that happening, but I'm sure that's possible. I mean, there is such a thing as too many transmissions, right? So, but there are also multiple channels. So I think they can have 8 or 16 channels on a per board, and you can assign different. So this is almost like a plain text version, a plain text channel. But then you can have an encrypted channel between different nodes, as I was talking about before. If nothing else, it's pretty cool. Any other questions?
Okay, if that's it, then thank you very much for your presentation.
Yeah.
The next speaker will begin at 3:25, so in 20 minutes here at Track 1. Hello, everyone. Welcome to our next presentation by Dario Sindicic called Kubernetes Discovery, Chaotic Cache, and How to Speed Up Your Velero Backups.
Thank you. I just figured it out that I discovered the solution in the title of my talk, but we'll be actually talking about how to speed up the Velero backups. In short, what we achieve if we have a car which runs maximum 70 miles per hour, we actually upgraded it, and it can actually run at 150 miles per hour. So it's a pretty nice improvement. But at first, a little bit about us, company, who we are. We are a government-owned company with over 50 years of existence. For you who are from Croatia, I found out a couple of days ago that we aren't the oldest IT company in Croatia. The oldest one is actually Ericsson Nikola Tesla. So this, and our main clients are Ministry of Finance, Tax Administration, Customs Administration, and the IT supports for the election. And there are a lot of small projects that comes from the government side. This is how the government works. And we are currently in the transition to mostly containerized environment. So we are kicking the mainframe out of the building. And those new stuffs need backup. So first of all, how many of you are familiar with the Kubernetes? Excellent. This is my type of the audience. So if you don't know anything, let's imagine that that those are all just texts. So we have a type namespace, we have a type config map. It can have a name and some data in it. And if you have some namespace A00 DORS CLUC dev, it can have various objects. So secrets, config map, some deployments that's running, image stream, and some service account. So nothing special, just a bunch of YAMLs. So basically a text. And if you want to backup it, you usually want to backup it on some slow disk or some tapes. And if you perform a backup, what do you expect? You expect a folder on those disks, which will actually contain all your objects. And if we are talking only about backing up the YAMLs, how fast do you think that all process should be? If you are talking, so this is a really small project. So all the text is actually around 5 to 6 kilobytes. So it has to perform around 1 second. If it doesn't, then something strange is going on. So let's create a backup. So in Velero, this is created by the backup create command. So let's name our backup DORS1, and let's just run it on one namespace A00 DORS CLUC dev. And when the backup is finished, let's take it a look. So the start timestamp was 1538, and the completion timestamp is 5040, 21. So this is a small project without any volume, and the total time is 95 seconds. And in our production cluster, we have around 400 namespaces. So the total, so the minimum time backup would be around 11 hours. And this is completely unacceptable. And of course, I couldn't show it to my boss. And if you combine some shame and curiosity, you get DORS CLUC presentation. And we will actually dig into to see what's actually going on. Let's wrap it all up and let's focus on the architecture. So let's draw it all up. So all job of Velero has is to is asking the API, give me all the resources from the namespace X. Give me all that. And the Kubernetes API here say, there you go. I don't care. And then Velero doesn't do any pre-processing of that. That's our assumption, and it's basically saving that in our case to mini IO to S3 storage. So in our case the mini IO. So if we take a look, it can be either this or disk throughput. That's causing our high backup time. So it's usually a disk, right? So let's check. If we combine the Valero log outputs together with the S trace of the Valero, we can see that the backup has completed in 00:45 seconds. That's in that time the all YAMLs are in the memory, and in that time we are actually connecting to the Minion server. We can see that port is 9000, and that we are writing some strange binary, and only thing that is readable is actually Guardian Minion SVC. It's actually the indication of the TLS handshake. And after that, we are just sending all data to the mini IO, and everything is completed in 00:46. So only a second. So it's not in the disk. So it has to be at the top. So how is actually that? And also what we notice in the log output is that we are getting a lot of client-side throttling. And we can see that we're waiting for 25 seconds, we're waiting for 11 seconds, it's quite a lot, quite a huge time. So after some Googling, we figured it out that all Kubernetes clients have some throttling parameters on their side. So there is actually the API is not protecting itself on their side. Is actually giving the client ability to not send too many requests. And if we type Valero server minus help, we can see that we can parameterize or actually increase the burst parameter and the queries per seconds parameter. So the burst parameter is the maximum number of the requests that client can send to the API in the short amount of time, and when that limit is reached, then the queries per second is taken into the account. And so we will pass client burst and client queries per second to the Valero, and we can see in the source code that we are setting client queries per second into the F object. So the F object is actually the factory. So when in the code we will ask for the new kube client, we will actually ask for a factory. Or instance, give me some new kube client, and it should have those client queries per second and the client burst parameter. And using the elbow method, we see that by increasing the burst parameter and queries per second, we didn't do much. So we come from 95 seconds to only 84. So not significant changes. And we can see that it's 250 and 550, we have no changes, so that means that we can stop increasing the burst parameter. So what does it mean? That means that some part of the Valero code is not receiving our parameters. So it's pretty strange. And again, at the highest parameter, we are again seeing those strange logs. So it has to be in the communication to the API. So let's analyze the API calls. But before we do that, let's do some revision. So we said at the beginning that all object has its type. But the special things about Kubernetes is that you can create your own data types. So the client, in order to know how to communicate to the API, he needs to actually fetch all of available information about all of the objects. And if you have around 500 types in your Kubernetes cluster at the beginning of the some job that the client needs to do, you need to perform 500 HTTP GET requests in order to send the first real request to the API. So how does all that works? So we have to discover all our types, and after we discover all types, we loop over them, and we are calling the Kubernetes API, so fetch me the resource of type T in the project P. So the project P is the project that we are backing up. And after we fetch everything, we are done in the communication to the API. So after analyzing our calls, so we started in 2045, and when we ended in 2218. And if we analyze API calls that are coming to the API, that are related to our namespace, it's only happening in the last 3 seconds. So all that, in all those 82 seconds, something is strange going on. So we see that our backup can actually be performed in 2 to 3 seconds because all relevant API calls are happening at the end. And what we also see, the increase in the burst period is actually only decreasing the last part. So the time for the API, the time for the objects to be reached from the API. So that strange red things, it hasn't completely changed. And what's that strange thing? That strange thing, so the green one is fetching the all resource from the API. So the red has to be the discovery of all resources. So client-side throttling are probably caused by discovery of all types. So let's fork code. Let's fork Valera code and see what's actually going on. So in the discovery helper file, there is a function refresh, which is actually running the discovery phase. And let's add some debug prints to see what's going on. So we are adding the debug prints, so running the Valera discovery cache, and we are actually printing the stack trace so we know who is calling the discovery. And at the end of the function, we are calculating the distance between epoch time, so we know how much time we spent in the discovery function. And if we compile that and run a Valera backup again, we see, so this is 2054, we're running this discovery, and our discovery is finished at 2135. So we have spent 41 seconds in this discovery. And then the discovery is running the second time at 2135, so sequentially, and it's done at 2216, so again, 41 seconds. And if we have, and in our cluster, there are 457 API resources, so that's equivalent to the 10 queries per second, which is quite low. And it's not that parameter that has been passed through the flex that we give to Valera. So from the stack trace, we actually discover that during the backup phase, the Valera is running plugins which are specifically Valera plugin for AWS because we are saving our backup on S3 storage, and it's actually spinning up a separate process and that process has its factory completely different settings from the default Velero one. So Velero process has completely normal boost parameters that we give them, but the plugin doesn't have that, and it's using really low queries per second and burst parameter. I didn't find where there are specification about why it's 10, because in the search in the Kubernetes documentation I found that it's actually 5 number, but there is a number 10 somewhere. And what we can actually do, we can set up the default parameters to our factory. So if we set the default parameters to be 300 and 600, and if those parameters are all override, okay, but in the plugin phase there won't be override, they will never be set. And if we compile everything again and run our backup will completely instantly in just 2 seconds. And thankfully to that, we can actually back up our entire production in just 14 minutes. And that's it. Thank you.
Any questions?
Thank you.
Thank you very much for this presentation. Our next and final presentations for this conference will begin at exactly 4 o'clock, so in 20 minutes. Sorry, everyone. Our last speaker is a bit late, and she will probably arrive soon. But yeah.
Nemoj ga tjerat, jadno. Evo ti voda. Dobro. What the hell? Neko me...
Stani.
All right. We have the correct presentation up. And just a few formalities before we close. This is actually how we close. Thank you all so very much for contributing, for being here. We hope you had a really good time. We hope you met some new friends, people, made new experiences. And before we go on with the closing, I would please ask you to give a big round of applause for all the organizers that were not visible, like a couple of us are. Thank you. Every one of them has been volunteering, so thank you, each and every one of you. Also, we will not be here without the support of Algebra University, so again, it's important to mention this, stream it and record it. We appreciate it very much, and thank you very much. Of course, our sponsors also played a big role in making all the little arrangements possible, all the, logistics, materials, food. Thank you to them as well. And next up, we have a couple of prize games that I will let Andrei tell you about what happened.
Thank you. So for the Smart Account prize game, I'm not sure this is how you translate. Nagrada igra, but whatever. So for the Smart Account prize game, the winner of the 6 months of free accounting is Christian Soldo. So if you're here, congratulations. Let's talk later. And then for the most amazing prize, every year we have this, and it's getting very, very nice, and people are actually expecting it. Here, now this year we have the live opening as well. I made it complicated on purpose. I hope he can read the handwriting later. Okay, let's see. Anje Pureber won the... There we go. Congratulations, you won the Python course. We'll connect you up with the heart.
So the formal part of the conference is over, and tomorrow and the day after we are continuing with the Unicraft Hackathon. So if you haven't registered yet, you don't have to. You can just show up tomorrow morning at 9 a.m. here at the B1 and B2. There will be, I think, around 10-15 people participate. Yeah, pizza and everything. I'm pretty sure it will be fun, so feel free to join. Yeah. And of course, after the closing ceremony today, we're gonna go to the Treasure Cafe for the conference party. I hope you all have the coupons for the drinks. If you don't have, let us know, we'll give you some. And that's about it. I just wanna ask you one more thing, is to go with us at the front of the building, and we're gonna take a group picture of all the attendees like we do every year.
We're not done yet. Just a second. Thank you to our wonderful speakers this year. We couldn't have done it without you. To our keynote speakers, please apply. We're already starting for the next year, Monday. We're also looking for sponsors. Again, please come talk to us. We're trying to scale this up to make it something more beautiful for the 30th occurrence, jubilee. I don't know how to read that word. So yes, come talk to us, contact us. We already made some plans with OpenIT and others.
If you have any suggestions for the 30th conference next year, let us know.
Okay, yes. Let's go take the photo.